All right, let's dive right in. Today, we're talking about the fundamental ways search engines are actually built to tackle the entire internet. You've got the centralized giants we all use every day, and then you've got this really clever, lesser-known alternative, the distributed model. So let's break it down.
I mean, have you ever really stopped to think about it? You type a few words, hit enter, and bam! In a fraction of a second, you get millions of results from this sprawling, chaotic thing we call the web. How on earth is that even possible? Well, it all comes down to the architecture, kind of like the secret blueprint of the search engine itself. Okay, so first up, let's talk about the reigning champion. This is the model that powers the massive search engines that we basically live on. It's the centralized approach, and really, it's all about one thing: building one giant system with massive scale and total control.
So here's the deal. To even attempt to index the whole web, these engines have to build absolutely colossal systems. We're talking thousands upon thousands of computers, all humming away in perfect sync, all working in parallel. They're grouped into these things called clusters. So don't think of it as just one big computer. It's more like a single, sprawling superorganism.
And this diagram gives you a pretty good idea of the flow. When you type in a search, your query gets zapped through a network to these huge server clusters. Now, because the web's index is just way too big for any single system, it's broken up into little pieces. Each cluster holds a different piece of that puzzle. It's an absolutely massive but incredibly coordinated effort to find your answer in an instant.
But what if you don't have the resources of a small country to build a planet-sized computer? I mean, is there a smarter way? A more efficient, cooperative way to do this? Well, that brings us to a totally different vision for web search, the distributed model. You know, way back in the early days of the web, a system called Harvest actually pioneered this totally different approach. The thinking was, instead of having one central company trying to crawl and index everything in sight, what if you could imagine a web where information was shared and gathered collaboratively?
Now, to really get how this distributed model works, we need to meet the two key players that make it all happen. They're called gatherers and brokers, and they are the absolute heart and soul of the Harvest system.
Check this out. You can immediately see the core idea here. Instead of one central crawler reaching out to the entire web, you have these things called gatherers that are positioned right next to the websites themselves. They collect the data locally and then pass it on to brokers, which are the things that handle your search queries. It's a completely different, decentralized flow of information.
So what exactly is a gatherer? The best way to think of it is like a friendly local librarian for a specific website, or maybe a small group of websites. It actually lives on or really close to the web server, and on a regular schedule, it just collects all the important indexing info. And the big win here? It means the server isn't getting constantly bombarded by dozens of different crawlers from all over the world. And the broker, well, that's the other half of the team. This is the part you would actually interact with. It's the search box. The broker gets its information directly from one or more of those gatherers that have already done the hard work. And here's the really cool part. A broker can even get information from other brokers. This creates this incredibly flexible, interconnected web of searchable data.
Okay, so we've met our two contenders. In one corner, the centralized giant. In the other, the distributed team. Let's put them side by side and really see the fundamental differences in how they get the job done.
So on one side, you have the standard model, which is really a brute force approach. You have one central crawler that has to go out and fetch everything from every single server all by itself. It takes immense resources. But on the other side, you've got the harvest model, which is all about coordination. The gatherer does the work locally, and the broker collects it. Information is shared efficiently rather than being taken forcefully. We've seen the how, but what about the why? I mean, you might be thinking this whole distributed thing sounds a little complex. Why would anyone bother? Well, let's look at the very specific problems it was designed to fix.
The people who created Harvest, they saw a massive advantage. They genuinely believed it was a fundamentally smarter, better way to build a search engine for the web as it was growing. And it turns out this model was built to solve some very real headaches. First, it dramatically reduces the load on web servers, right? Because they aren't getting hammered by countless different crawlers all day. It also cuts down on web traffic. The gatherer just extracts the index info it needs instead of downloading entire web pages over and over. And maybe most importantly, it solves the coordination problem. You don't have 10 different companies all redoing the exact same work. You're sharing the load.
When you boil it all down, it really comes to this. The standard model we use today is all about centralization.
one massive entity doing all the heavy lifting. The distributed model is all about cooperation, lots of smaller parts working together in a much more efficient, coordinated way.
And that leaves us with a really fascinating question. There's no doubt about it. The centralized model, the one giant brain, it clearly won the first era of the web. But as the internet grows infinitely more complex, you got to wonder, what's better suited for the future? An even bigger giant brain? Or maybe, just maybe, a return to this idea of a whole network of collaborating minds? Something to think about. Thanks for watching.